Hello everyone. In this video, I am going to discuss a three variable K-map. Up to now, I have explained the two variable K-map, how to simplify the Boolean expression using two variable representation. And now I am going to discuss about the three variable K-map. Already I have explained basic introduction of the three variable K-map. It has totally 8 cells. These 8 cells are arranged in 2 rows and 4 columns, or 4 rows and 2 columns. Anyone we can take. And now onwards, I will take here one variable row side and 2 variables column side. So that means here I will take completely 2 rows and 4 column representation. First of all, I will draw one simple Karnaugh-Map. These are the three variable K-map representation. First of all, we'll go through this one. First of all, I'm taking one simple example. One simple representation is given here. Sigma m 0, 1, 6, 7. These combinations are given, and finally we have to simplify the Boolean expression using K-map. So to solve any Boolean expression or any given problem statement using K-map, first of all we have to identify the number of variables. So to write the Boolean expression, how many variables are required? First of all, we have to identify that. To identify the number of variables, take the maximum number from the given combinations. Here, all these are comes under SOP terms. Sigma m is given. So sum of product terms, because this symbol explains the SOP. And from this, we have to take the maximum number. Here, the 7 is the maximum number. Just write 7 in terms of binary format. How many minimum number of bits required to write the 7? So I'm writing 7 in terms of binary. It takes totally 1, 1, 1. That means it requires 3 bits. So identify the maximum number. From that, convert into binary number. Then it gives the number of possible bits to write that number in terms of binary format. So then it explains the number of variables. So now it requires totally 3 variables. So to solve this problem, compulsory it requires 3 variable K-map. So now I wrote 3 variable K-map. Those variable I am assuming are A, B, C. And based on the given combinations, sigma m 0, 1, 6, 7s are given. So 0, 1. Note on the numbers. This is a minterm 0 and minterm 1, minterm 2, minterm 3, and this is 4, 5, and here is 6 and it is 7. So already we have discussed these combinations, positions, values, right? And now just I am indicating 0 and 1. Minterm 0 denoted by 1 and minterm 1 is also denoted by 1. Why it is 1? Because it is a SOP expression, sum of product form. And 2, 3, 4, 5 are not there, and 6, 7 also given here. 6 and 7. These two are also denoted by the 1. If the expression is SOP terms, indicate those positions by the 1, and if it is a POS expression, then indicate those positions by the 0. Now we have to apply mapping now. How to map? It is a 3 variable K-map. First of all, we have to check a 2 power 3 group of cells. 2 power 3 means 8. 8 group of cells. That means octet. Octet not possible here. Later, we have to check for 2 power 2 group of cells. 2 power 2 is a 4. So 4 group of cells directly not possible, because 2 cells are defined here and 2 cells are defined here. Directly we can't combine 4 group of cells at a time. Later, we have to go for 2 power 1. So 2 power group of 1 cells, this is acts as a 2 group of cells, and this one is also acts as a 2 group of cells. Totally it has 2 pairs, and all ones are mapped. All ones are mapped, then don't go through the 2 power 0, that means single term. And here once it is mapped, and don't take internally 1 term as a single term representation. So all ones are mapped. Then finally we have to write the expression for that. See, first of all, I am preparing the expression for this pair. It is a pair now. Group of 2 cells is nothing but pair. So first of all, write the expression for this pair. This pair consists totally 2 cells. This cell combination is 0, 0, 0. So 0, 0, 0. This cell combination is 0, 0, 1. 0, 0, 1. Now from these 3, first 2 bits are same, but the third one is changing here. So just remove this. Remove this and write the remaining 2 with the variable names. So this is A bar and this is a B bar, because the bit position is a bit value is 0. That's why we have to indicate by the bar. So A bar, B bar, C variable eliminated, right? Otherwise, we can write directly also. I will explain the directly how to write the directly. See, after this mapping, after this pair combination, just try to check this pair consists of, this pair covers how many rows and how many columns. So now this pair covers the one row and the two columns. Then find out the row combination. Row combination is 0. Fixed value is there. So that's why here we have to write this is a bar. And what about the column combination? Columns combinations are two variable, two representations are there. One is 0, 0 and another one is 0, 1. So 0, 0, 0, 1. In this second bit is changing 0 to 1. Second bit is changing. That's why we have to remove the second bit. But first bit position where first bit value is 0 only. So that's why we have write that is a B bar. Otherwise, write this combination B bar, C bar, and this is a B bar, C. From these two columns, which one is common? B bar is common. So finally, you have to write A bar, B bar. And similarly, I want to take this pair expression. See, this pair covers the one row, two columns. This row value is 1, so we can write as a and these two columns here 1 1, so BC, because these variables are BC, and 1 0, so this is a BC bar. Now we have to take the common literal from these two columns. So B is a common term and here A is there. So finally we can write the simplified equation is A B, right? Then write the summation form. SOP, sum of product term. These are the individual product term. Then write the summation F is equal to A bar B bar plus A B. This is equal to A XNOR B, or we can write A XR B complement also. So XR and XNOR, these are comes under logic gates. So we will discuss this XR and XNOR operations in logic gates. Here just I explained how to simplify the given SOP terms here, right? So 0167 is given. Now similarly, here I am taking one more problem statement. Sigma M 01235. So one simple combination is given like this: sigma M 01235. In this, the maximum number is 5. 5 converted to binary format 101. So 3 bits are required. It's a 3 variable expression. So compulsory we have to draw 3 variable K map. First of all, draw the 3 variable K map and indicate those positions 0, 1, 2, 3 and 5. Now go through the mapping. So within the mapping, first of all, we have to check all 8 group of cells. 8 group of cells are not possible. Then go for the 4 group of cells. So 4 group of cells are possible here. These 4 bits are acts as one group. So it is acts as one quad. So number of quads, how many? 1. And one more 1 is there. So next group of 4 group of cells are not possible. Then we have to go for 2 group of cells. So when 1 is there, if you combine this 1 by this one, right? So then it is acts as a one pair. So we can combine one mapped one with external ones also. Here already these two are mapped. Again, don't write individually like this. But in this case, one extra one is there outside of this map. Then if you combine with this one, then it is acts as a one pair. So group of 2 cells, that's why we can take it as a pair. So now write the expression for pair. If you want, write here for easy simplification purpose, write here expressions. This is A bar and this is A, B bar, C bar, B bar, C, BC and BC bar. Now go through this pair. This pair covers the totally 2 rows. These 2 rows combinations are 0, 1. So not fixed value, it is a changing. So remove that. And it covers the only one column. This one column representation is 0, 1. So 0, 1 is the fixed. That's why we can write the equation is B bar C. Right? Similarly, now I want to write the expression for this quad also. The quad. This quad covers the 1 row, 4 columns. 1 row equation is 0. So A bar. And 4 columns. Just observe the 4 columns positions values, binary data 0, 0, 0, 1, 1, 1, 1, 0. So every bit is changing. That's why we have to remove B and C variable. So there is no common term, common literal from these four columns. So where the simplified equation consists only a bar. Then finally we can write the simplified equation is a bar plus b bar c. So this is our simplified equation. Similarly, we have to apply the same procedure to the remaining problems. So I want to explain some other examples.